The third section we'll cover in Chapter 4 is about theorems. We do have a lot of theorems to cover in this section, so make sure that you are paying close attention and make sense of all of them. First of all, before we jump into theorems, let's make sure we understand exactly what a polynomial is. A polynomial is always written in the form f of x equals a sub n of times x to the nth plus a sub n minus 1 times x to the nth minus 1 plus so on and so forth until we get to a sub 1 times x plus a sub 0. For example, if we actually plug in numbers, we could have something of the form 6x to the 5th minus 4x squared plus x minus 15. Well, there is an implied x to the 4th and x to the 3rd. We do have a x squared. There we go. But they just have coefficients of 0. But every polynomial is written of this form, where we have a string of x's of decreasing exponents, each with their own coefficient. So in this generalized form, all the a's are the coefficients. We see that the a to the n, so a sub n times x to the nth is called our leading term. And that's the term that has the highest exponent, which means that a sub n is the leading coefficient. And then lastly, we see that a sub 0 is what's called the constant term. So that's a sub 0, and in this case, the negative 15. Please make sure that you understand this new vocabulary if it's new to you. Leading term, leading coefficient, and a constant term. Also know that the polynomial is said to have degree n, where n is the highest exponent, and we write that as degree f equals n. For example, if we are given g of x equals 2x to the 4th minus 8x cubed plus 200x minus 625, we see that the leading term is 2x to the 4th. The leading coefficient is 2. The constant term is negative 625. And the degree of function g is 4, because our highest exponent is a 4th power. Make sure that you have these definitions, these ideas down before we move into the theorems, because we'll be using this terminology, we'll be using it fluently enough that if you don't understand what it means, it's going to be very hard to make sense of the theorems.